Welcome everybody to this workshop. Unfortunately, Christopher Bontam should be coming in now and he's having some troubles logging in. He should be presenting the next sessions. So we'll just go on and proceed with the presentations. We're going to have three very nice presentations, I'm absolutely sure. And the first one is by Ian Holtz. It's from data to visualization. Ian is a software engineer who specializes in data visualization and works for Datadog. He has worked previously in academia as a data analyst, and his passion for data visualization has led him to develop websites like Data to Viz, and also the R, the Python, and the D3 graph galleries. Without further ado, and I'm still hoping that Christoph will come back and will probably do a better description of the work of these three colleagues. Without further, I will go on and pass it to Ian, please. Ian, can you start your presentation?
Yeah. Hello, everybody. Thank you very much for the introduction. I hope you can hear me well. I'm going to try to share my screen now. Here we are. So hopefully you can see what I see. Please tell me if that's not the case.
Yes, we can.
All right, cool. So let's get started. As you've just said, I'm Jan Holtz. I'm a software engineer passionate about data visualization. And I'm going to talk a little bit about what I've done so far and what's my process to create a new data visualization. So first of all, let me tell you a little bit about what I've done in the past, like 10 years or so. Basically, my job has been to help researchers, students, private companies, organizations to better visualize their data. So I started to analyze stuff about genetics, then stuff about mental diseases, then stuff about agronomical science. Now I'm working in the field of technology, and my job was always a little bit what we've got here. I was sitting at my office and somebody will come to my place and say, hello, I've got this data set. What do you think I should do with it? Sometimes it's a very big data set, sometimes it's very small. On that screen, it's a very small one. And my job is, and so that person will come to my office and will say, what should I do with my data? And sometimes they've got a very great idea that goes with it in their mind. So a very beautiful bar chart like that. So my work was to help them get some better visualization to show their data a better way. So that's what I do. Like, I'm between two worlds, the world of design. So basically you've got a data set and what's the best way to represent it. And the second world is how to actually build this new visualization. And so in my career, it's been about coding, because most of the time creating a nice viz is about coding. We're gonna talk about that later. So what I would like to do in this talk is to share the process I use to design and code some new charts, to create them, to give you a few insights about my process. And all along, I'm going to show you some websites I've built to help people in this process. So that's the very big picture of my process and the very big picture of my talk. When I've got a new data set coming, what I first do is I try to check what I can do with this data set. What is the set of V's I could potentially build with it? Then the second step is to actually pick one of them, choose what's the best one in the list I've got from step one. Then I always gonna check what are the major caveats that goes with that kind of chart. In database, there is like this list of like very usual mistakes, and it's better to try to avoid them. So it's better to check them one by one in your hand. And the last step, which is probably the longest one, is to actually build the chart. So that's going to be like the four parts of my talk today. So let's start with part one. What you can do. So first of all, why is it important to check everything you could do with dataset? So let's say you have this data on your office, and something come to your mind, and you're pretty sure you have to do a scatter plot with it. Scatter plots are very common, very useful to check correlations. It makes sense. So you do a scatter plot, and as a metaphor, you got this lion eating a baby. And you're like, oh, great, that's what I've got in my dataset, done. But actually, maybe if you represent the exact same dataset using another type of viz, let's say a 2D density chart, you're going to see that actually there was some overplotting in your scatter plot, and a message was hidden in this scatter plot, because actually, if you look at the picture on the other side, the lion is not eating her baby, but yeah, just pulling it up. So what I'm trying to say here is that it's almost impossible to know from the very start what's going to be the best viz for your data. It's better to try all of them, test all of them to make sure you're not missing anything, and make sure you're going to find the right viz for your data. Cool. Let's keep going. So let's consider this very, very simple data set. You've got two columns. The first column has a country name. The second column has a numeric value. It's actually the amount of weapons that has been sold by this country in 2017. So yeah, let's use it as an example. Let's say you've got that on your desk. What are the viz you can build with this data set? Please try to take like 10 seconds in your mind and make the list of all the viz you could do with this dataset. As you can see, it's a pretty simple one, so there are probably not thousands of them, but try to list them just to check how many of them you know. All right, the 10 seconds are probably over, so let's make a review. So hopefully you found that one. So the first one is what we call the bar plot. You've got one bar for each country, and this bar is more or less long depending on the value. It's pretty cool because if you rank it, then you can know what's the rank of all the countries, and you can also see the difference from one country to the other. So you can see that United States is selling 2 times more weapons than Russia, and so on. So that's like one of the most common type of viz. I'm pretty sure you know it already. Then you've got what you call a Lollipop Chart. It's pretty much the same thing, but instead of having a bar, we've got a segment with a circle. It's pretty much the same thing, but it's great sometimes because you have less like clutter on your chart. It's less dense. It's easier to look at, especially if all the bars are pretty long. So yeah, that's like a slight difference, but sometimes it can be interesting to explore it. And then you've got something that is a bit different. That's what we call a circular bar plot. So it's basically the same thing as a bar plot, but it's circular. So maybe you didn't know that one. It's less good in terms of science because it's less accurate. It's harder to compare bars one to each other. But the good point with it, it's visually appealing. People like to look at it because they don't know it and it looks kind of pretty. So sometimes it can be interesting to use it as well. And then we are entering like a complete different world. That's called a tree map. Each country is represented as a rectangle. And so you can see that United States has a very big rectangle here. It's very interesting as well because here it's much harder to see what's the rank of countries, but it's much simpler to see that United States are selling pretty much 1/3 of all the weapons sold in the world. So here we're not watching the same thing. We don't see the rank, but we see what we call the part of a wall. What's the proportion that one country represents? And when you can do a tree map, you can also do what we call a circle packing chart. So here, instead of representing each country by a rectangle, you represent it by a circle. Pretty much the same thing, but visually a bit different. So what I'm trying to say here is that with this very simple data set, there are already many kind of viz that you can build, and maybe you don't know all of them yet. And it's definitely worth trying to know a bit more about them to make sure next time you've got a data set to visualize, you've got like the biggest panel of stuff to explore. This morning there was like the workshop with Edith Mondi, and they've done that. So basically, on the y-axis here, you've got a chart name, and then she asks to everybody in the workshop, that was 35 people, if they knew the chart type and if they made one already. And as you can see, like even among 35 people that are highly interested in data viz, only less than 25% of them know like what a violin chart is or what a Sankey chart is. So of course, when we're talking about pie chart, everybody knows what it is. Histogram as well. But there are so many types of viz that some people don't know, and it's definitely worth trying to explore them. That's like one other example to highlight that a bit more. Here you've got some, oops. Yep, that's another data set to explore it a bit further. We've been asking to many people what does likely mean, for instance, in their mind, to like rate it from 0 to 100%. Like, what's the probability of likely for you? And here we can see that somebody says likely is about 60% of chance to happen. Unlikely is 10% chance to happen. So this data set is a bit different than the other one. We still have two columns, one categorical and one numeric, but this time we can have several observations per group. And as a result, there are some other kind of views that we can build with it. Because here, each time, instead of having just one value for one bar, we can do, for instance, a box plot with it because we have several values for one entry. When you can do a box plot like that, you can do what we call a ridgeline chart as well. You can use small multiple to show the distribution of each entry, or you can show all the distribution on the same chart. So as you can see, like when the data set becomes a bit bigger, a bit more complicated, then the number of these you can create are getting more numerous and a bit more complicated to build as well. So what I'm trying to say here is that it's definitely not trivial to go from one data set to all the V's you can build with it, and it's definitely worth thinking about it. So knowing the possibilities is the first step in a chart choice. It's not easy to know all the chart type you can build with one data set. And because of that, because I was always having the same plan, same process in my head, and I was like talking about it with many people, I decided to build a website about it. And this website is called From Data to Viz, and the main part is a decision tree. So basically, you describe your data, you answer a few questions, and then it tells you all the kind of Viz you can build with it. So I'm going to try to give you a quick demo on how it looks like. So hopefully you can see my screen again. All right, now you're seeing it, right?
Yes, yes.
All right, yeah, that's annoying. Anyway, sorry for that. I didn't know it doesn't work like Zoom. So yeah, like I do it shortly again. That's the decision tree. You choose what kind of data you have here. You answer a few questions here. It leads you to the kind of database you can build with this data set. So yeah, let's say I've got two numerical variables. They are not ordered. You've got a few points only. Then you can build a histogram. You've got a short description here, and when you click on it, you've got a very thorough definition of what a histogram is. It explains you when it's great to use it, what are the most common variations around it, what are the most common mistakes. And the good thing as well, if you use R for your work, you've got the reproducible code here. So basically, if you copy and paste this code in RStudio, for instance, you can have the same chart. We're gonna talk about it later. So yeah, that was like a very short introduction to what From Data to Viz is. All right, so that's the poster that we are having that goes with the website. And so now I've finished the part one, and because we're a bit late, I'm not going to show that, but That's like a website that does a list of all the weird data viz that exist in this world. And I think it's great to have a look to it, to have a look at it if you've got a bit of time one day, because it shows you how infinite the world of data visualization is. Basically, there are like so many possibilities. It's impossible to list all of them. And this website tries to show some of them that you for sure don't know because they are like very unusual. All right, so that was like the step one. The step one, now, when we've got a data set, we're able to list all the potential graphs that we can build from it. But the job is far from over because now we have to think about what's the best option for our work to display. So how do you make this chart decision? When I have to decide which chart is better, I try to answer this question. What's the question is, like, why is my chart interesting? What I'm trying to do with it, what I'm trying to show with it. Is it like explanatory or exploratory? Am I trying to know more about the dataset myself? That's exploratory. Or am I trying to explain stuff to people? That's explanatory. Who's reading it? Am I talking to students? Am I talking to people in the streets? Am I talking to scientists that all have a PhD? What do we have in the data itself? Where do I need to display my data viz? Like, is it like on a piece of paper? Is it in a Word document? Or is it on the web? It's on the web, it can be interactive. Otherwise, it has to be static. And it can have like a great impact on the decision I have to make. And lastly, do I want to have something very accurate, like for a scientific paper, or do I want to catch people's attention? In this case, I can do something way more eye-catching, even if it's not as accurate. So let's review a few examples together. Here on the decision tree I've showed you, there is a color for each logo, and this color depends on what you're trying to show with your data. So in the example we've seen a bit earlier about weapons sold in the world, if you want to see what the ranking is, then you probably want to have a bar chart. It's the green color here. However, if what you're interested in is knowing what's the proportion of the weapons sold in the world by each country, then it's probably better to do a tree map because it's going to be easier to see what's the proportion of the area on the tree map. So that's like an example where, depending on the question, you're going to use one viz or another. So it's important to keep that in mind and make sure you know what you're trying to show. Then there is this question about exploratory against explanatory. So what you're looking at right now is what we call a parallelogram. So it's a set of charts, and like it's gonna show you a scatter plot for each pair of a data set that has numeric columns only. So that's like the relationship between column A and column B. That's the relationship between column A and column C, and so on. And the color shows a categoric variable. So it's like group A, group B, group C. What I'm trying to show here is that it's going to take time to read this chart. If you're like exploring your data, you're going to be very happy about it because you're going to be able to spend 5 minutes on each subplot, and maybe you're going to understand what you're trying to understand. But if you're showing that in a conference, like everybody's going to be very focused on what's shown on the chart. They're not going to listen to you anyway, and they're not going to get the key message you're trying to pass to people. So always make sure that the chart type you're doing is appropriate, depending on if you're exploring the data or explaining a data set. If you're explaining a result, it's better to add like some annotation to show that like one bar on one dot is the answer to your question. If you're exploring your data set, you can do something very complicated and take like hours reading it and trying to understand what's going on. Then there is this question of who's reading your chart. What you're looking at is what we call a hierarchical edge bundling. It shows the relationship of many items that are split in a hierarchy. So basically, if they are connected, it means there is a connection between both. and the shape of the line that joins them depends on the hierarchy. So it's beautiful, it can be very insightful in some condition, but if you're showing that to somebody in the street who doesn't know much about these, he's probably going to be lost and he's probably not going to get any insight from it. If you show it to somebody who's got a PhD, who's very used to analyze data, then he's going to be interested and he's probably going to know more about it. So what I'm trying to say here is that please consider who you're talking to, and if you're talking to somebody who doesn't know about this, don't do complicated, and the opposite is true as well. Then there is this question of interactivity. So for instance, if you do a bubble chart here, it's very handy to have a tooltip on top of it. So when you hover a dot, you've got this tooltip with additional information. If you're doing something static, sometimes one chart is not going to work because you need to have this interaction to go further and get some insight from it. So yeah, always keep in mind if you're working for the web in a browser, or if you're working on a paper on something static, and maybe the viz you need is not going to be the same. And then there is this question of eye-catching versus scientific. More like accurate viz. Here, that's a circular bar chart. We've been talking about it before. It's beautiful, people like it, but it's much harder to compare one group to another. So for instance, here, if I take Kenya and I have to compare it with Morocco, it's very hard to know which bar is the longest. But if you put one each beside each other, then it's going to be much simpler. So yeah, there is like a trade-off between both. I'm not gonna like demo it, but that's like an animation of the number of people dead in France in the last 20 years. And what I was trying to say here is that it's an animation, so it takes about 30 seconds to get the full shot. So basically when I reach that kind of viz, it drives me crazy because I have to wait 30 seconds to have like the final result and know when in time there were like the most people dead. So it drives me like crazy, but people love it. You got like 16,000 people liking it. So in my opinion, that's not a good viz in terms of like science. It's not the best way to show the information quickly, but because it's beautiful and funny and it moves, people love it. And so you can attract more people's attention. So it can be very interesting sometimes. On T's world, I would like to give you like to demo the second part of the data to this website. Yep, it's what I call data story. So basically, for each kind of tree branch, you've got like a little story that analyzes a data set of the real world and shows you that indeed with this kind of data, you can build this kind of viz. So here I've clicked on visualizing geographic connections. So if you've got a data set like that with as a source in a travel country, then you can do like what we call a connection map. So it's going to tell you like how to do it in R, explains what are the caveats, what is dangerous, in which case it's better to do it, in which case it's better to avoid it. The code is always available here, and at the end of the day, it gives you like a nice map. So for the story, here I've been harvesting some tweets of people talking about surf, and I got like where they were located when they tweeted and where they live. And it allowed me to check like where people went for surfing in the past like 2 years. And like, yeah, I've been using like more than 10,000 tweets for that. So for each kind of data, I've tried to write a little story like that to explain in which case you should use which is. Here we are. That's all right. That's another story I'm going to skip because I'm late. So that was like the second part. So now we've got the list of all the viz we can do. We've got some knowledge about what to consider to choose what the best chart is. And the first step in my process is to make sure we don't do any very big common mistakes of the data viz world. So for instance, I'm pretty sure if I show you that kind of viz, you're gonna yell at me because you're gonna say it's not great viz, and indeed. We've got many issues here. We've got a pie chart. We've got the use of 3D when it's not useful. We've got colors that are irrelevant. We've got percentages that don't add up to 100. Like, that's totally wrong. It's like many of the most common caveats you can do in database. So if you know what the caveats are, then you're probably gonna avoid doing that kind of chart. By the way, T's website called What the Fuck Visualization is very good at it. So yeah, once more, if you've got a bit of free time, feel free to browse it, and you will see, like, that's a very good way to learn how to build some good Vs, actually avoiding the bad one. Yeah, well, that's a bit more about pie charts. If you look at 2, 3 pie charts, it's pretty hard to see what pattern there is into it. But actually, if you do exactly the same using a bar chart, you can see that on the first one, there is this evolution from A to E, with E being bigger than A. On the middle one, it's pretty like equivalent, and on the last one, it's decreasing a lot. That's like another very common caveat where you've got this Lollipop chart here, and it actually looks much better if you reorder it. So that's kind of simple. It's kind of obvious when you see it and you know it. But if you don't, then you're going to show your reader thesis figure, and they're going to be very disappointed. It's going to be much harder to read it and understand it. That's another one with box plot. Basically, box plots are dangerous because if you show the individual data points behind each box, sometimes you can have like a lot of circles, a lot of data points, sometimes just a few of them. Sometimes you can have a bimodal distribution and you're not going to see it. So that's another caveat, like always show all the data you've got behind your shape. Don't never hide any data. If you've got everything, show it. You can do a violin plot to represent that as well, instead of a box plot. What I'm trying to say here, it's that it's very common in the real world, like at TV, in advertisements, anywhere, to see some database caveats. Here, you've got these Vs that's showing the that's showing the economy, the gross domestic product of many countries. And on this chart, it looks like United States is much, much, much higher than all the other countries. But actually, United States is supposed to be only 3 times higher than China. So that's like another common mistake where size is proportional to radius instead of area. And so if you correct it, it looks like this figure on the right instead. And the difference doesn't look like that big. So I think it's very important to know what are the main caveats, and it's linked with what Christoph said about how we can lie with graphics. Because indeed, if we use the right technique and do the right mistakes, it's possible to make the data lie. I'm going to share my screen once more. I'm sorry, it's taking ages each time. Here we are. That's the last part of data to viz I would like to show you. There is actually like a gallery of all the most common caveats you can have in the world of database. So I've been talking about ordering your data. There is this very common story about should you cut or not the y-axis. What's wrong when you've got like too many lines in a line chart? It gets like what we call a spaghetti chart. What's wrong with the pie chart? And so on. So when you click on it, you've got some explanation about it. It explains why it's bad. And more importantly, it explains what to do to correct it and to make something better instead. And always with the R code. So yeah, feel free to have a look at it and see like if there are some of the common mistakes that you do in your everyday work. So that was the step 3, avoiding to do any mistake. I made it short because I know you had a talk about how to lie with graphics, so it's highly related with it. So that's why I made it very short. And because I made it short, I should have a bit more time to talk about how to do it. So once you've got so you've got the list of charts, you've got the one you've chosen, you know what the mistakes are. So you basically design the idea. Now you can draw it with a pen and paper. You know what you want, but you still have to build it. And actually, in the database world, we talk a lot about the design part. but in my opinion, most of the time it's much longer to actually build it. I will say in average it's a 20-80 ratio, but it can probably it can probably go from 199 to 99.1, depending on which tool you use and what viz you're trying to build. So what I would like to show you here is like an overview of all the tools that exist to build viz in the world. They're going to start from the left. So left are like tools that are easy to use, but that are very limited. And on the extreme right, you will have tools that are very hard to use, but very flexible, so allowing you to do more steps. The first one is Excel. So you're at the very left of the graphic because it's very easy to use. So here I've done like 2 columns, A, B, C, D, 1, 2, 3, 4. And in 2 seconds, I'm able to have a bar chart. So it's like very easy. If sometimes you have like very simple chart to make, like do not hesitate, you use it, it's awesome. However, it's very limited. If you have to do it 10 times, you're gonna have to click 10 times. It's easy to do mistakes. It's hard to customize the charts. You cannot really do anything interactive. There are a lot of limitations, so it's impossible to like do all your work with it. Most of the time, you're gonna need some other tools. The second group of tools I would like to talk about are tools where you do everything by clicking, but that are made for data visualization. The most famous one is probably Tableau, but there is another one I really like, which is called Data Wrapper, and I see that you've been using it during the workshop. Yeah, my plan was to give a short demo about it, but I'm gonna skip it because like we're a bit late on the timing. But basically, it's a tool where you enter your data and then you click to have some options and decide what chart you can have. But because it's been made by very smart people, it allows to make some great chart that look very good with good defaults that you can embed in a website or upload at PNG. It's like I advise very strongly to have a look at it. When I was working in academia, a lot of researchers were losing hours of their time to build a simple chart with R or Python. In my opinion, it will definitely make sense to try to use that kind of tool to save time. We're okay with the time. Okay, so if we're okay with the time, I'm gonna give you a short demo. All right, so that's Data Wrapper. I'm not gonna lie, I don't know this tool very well because I'm a programmer. So when I do something, I code it. But I will still give you like a very simple demo of what it is. So you can click on Start Creating. Then you go on your Excel sheet. You copy and paste your very simple table and you paste it here. If you don't see that I'm pasting something, please tell me. So that's the step 1, upload data. Then you do proceed. You check it. It's very simple, so there isn't much to check. So I can proceed. And now you're in the visualize part. And so let's say I want to have a bar chart. I can click on bar chart. As you can see, it's smart. It makes it horizontal because it's usually better to have a horizontal bar chart and because it's easier to read the labels. And then you can refine it and change whatever you want on it. It's pretty much possible to change everything. Let's say I want to have red bars instead. Let's say I want to have my table, and that's it. You get a nice bar chart and you're ready to go. So that was like a very, very quick demo, but of course you can upload some more complicated data sets. And I don't know, hopefully it can save you time next time you've got a nice viz to build. All right, so that was the second part, the second group of tools. And that's the third group of tools. So now we're starting to code. I know there are like a lot of different people in the audience, so I'm going to try to explain a little bit what coding is. So basically coding is just you write a couple of letters in a terminal and you get a result. There are many programming languages, but for data analysis, 2 of them are very famous, and they are called Python and R. I know R better, but I love Python as well. And to be honest, they are very like similar together. So you can go using one or the other. There are some other ones that I know. Julia is very good as well because it's open source as well. But it's a bit like lesser known. Then you've got some of them that you have to pay for it. So I don't really see the point of using them because you can do basically everything with R and Python, so it doesn't make sense to use SAS or MATLAB, in my opinion. But they are very like common, so that's why I've written them in the diagram as well. So I would like to give you like a very quick demo of what R is, how it works, and how to build a chart with R. And I would also like to show you another website I've built, which is called the R Graph Gallery. So let's do it. So the R Graph Gallery is a website. So you're going to recognize the logos, which are looking pretty much the same. It's a website. It's a collection of charts made with R. So if I click on density, for instance, I'm going to have a bunch of density charts made with R. So let's say you're interested, this one, the most simple one. You click on it, you've got some explanation, and you've got a code that is commented that explains you how to build it with some dummy dataset. Tells you like how to customize it. Depending on what we're talking about, it's going to give a lot of explanation or just a few. And so, yep, let's say you're working with your data and you want to apply it. You want to use this kind of chart for your data, then you can open RStudio. So I guess you're not going to see my screen again. That's RStudio, so that's where we code. And I'm just going to copy and paste this code. And here I am. I've got the exact same chart here on the right. So here I'm reading some table of data. So instead of using this dataset, you can just use yours instead. And you're going to have the same chart for your data. And so it's pretty handy to start with. So yeah, that's R. Something I would like to show you as well. It's like a very common task in data visualization is to build some reports. So let's say every day you've got some new data from the day before, and you want to have a report to show it to your boss or to your colleague to understand a bit more what's happening in your company or in your research institute or whatever. There is like a tool that I truly love in the R world that allows to do some report where you're going to show some text, some code, and some results in the same file. And it's called R Markdown. And yeah, let me show you how it works quickly. So I'm going to do a new file, R Markdown. I'm going to use a template I've created, which is called F8 here. I'm going to say, OK, that's not a problem. And I'm going to write, I'm going to remove like the default template, and instead I'm going to copy and paste the graph I've just showed you. All right. So that's how it works. You've got a header with like the title of your document. You've got some sentences where you can write whatever you want. You've got some titles here with a hashtag at the beginning, and then you've got some code. And when you click on the knit button here, it's gonna run this script and create the report for you. Here we are. Now I've got a very clean report made from this little chunk of code. Here I've got my plot, my explanation, the code for the, oh, that's annoying. That's the code for the chart. And so this is just like a HTML document. So you're ready to share it online or to send it by email or to keep it somewhere. And you can like make it automated. So every single day it's going to run and make the report for you. So that's called R Markdown, and it's a very cool way to share your viz with people instead of copy and pasting PNGs. Yep, that's the end of this demo. All right, that was the third part. That was the third group. And then there is the last one, and I'm reaching the end of my talk. So the last one is if you need to go further, especially if you need to create interactive charts that are displayed in the browser. So basically, when you see a graph that moves, like you've got a tooltip, or when you click on a button, you see like all the circles that are moving and going somewhere else. If there is like some interactivity, it means 99% of the time that it's using JavaScript under the hood. JavaScript is the language we use to create websites. And there is this very famous library called d3.js that allows to create some viz with JavaScript. And so like that's the next level here. We are on the very right part of the diagram. So it means you can do basically everything you want because you're building like each circle in each rectangle one by one, giving their position on the screen. So you can do basically everything, but it also means that it's very hard. It takes a lot of time to build a viz with it. So I'm gonna make. All right, I'm back. Yeah, last demo, I promise. I've built another website that is called the D3 Graph Gallery. So I guess you understood what it is. But it's pretty much the same thing, but using D3 instead of using R. By the way, there is the same with Python as well. So let's go to the same kind of chart, very easy, very simple density chart. If you click on it, it's always the same. You've got some explanation, and then you've got the code to build it. What I would like to show here is that the code is much more complicated. It's like very long just to build this small chart. So that's the bad part. You need a lot of time and you need a lot of knowledge to be able to build a chart with it. The good part is that you can do absolutely everything with it. I'm going to show you what we build at my company. My company is called Datadog, and I work in the DataVis team as a software engineer. And so we build that kind of dashboard where, for instance, you can add a time series, say what kind of data you want to use in your time series, and then you're going to have this kind of tooltip. If you click on it, you're going to have a context menu to do some more stuff with your data. If you zoom on it, you're going to be able to zoom in the time frame. And for instance, we build what we call the network map, which is pretty cool in terms of viz. So each dot here is what we call a service. It's like computer science stuff. And when you hover it, you can see which other service it's linked. So here we've got like a very high amount of interactivity, and the only language you can use to that is JavaScript, and it really is. So yep, that's what we do at work. And so yeah, that's like the overview of that's like the way I see the ecosystem of tools that you can use to create some viz. Excel, very easy but limited. Clicking tools, coding tools for data analysis, coding tools for the web, harder but unlimited in terms of possibilities. That's like a summary of the tools I've created and that I've showed you. So you've got from data to viz that's gonna help you to decide which charts to make. It talks about like general knowledge about data viz, and then you've got the R, the Python, and the D3 graph gallery that I hope will help you build your chart if you try to build them coding. And yeah, that's my last slide. If you want to hear about data viz a little bit, I'm called rgraph gallery on Twitter. If you want to have two slides, I'm gonna put them on the web tonight on my GitHub account. So it's GitHub alt.y talk. The repo name is talk. Yeah, I've got a homepage if you want to know a bit more about what I do. And I don't know if you have any idea, any suggestion, any feedback. That's my email in case you want to contact me. And yeah, it's been like 45 minutes, a bit more, and that's the end of my talk. Thank you for listening.
Thank you very much, Jan, and sorry for arriving late. Some traffic jams sometimes happen on my computer and in my head too. So sorry for this delay, but I think from what I've seen, that is the most part of your presentation. You really share your passion for data viz, and I'm pretty sure all the audience here enjoyed the huge amount of work you did constructing this website, which I can tell you as a teacher that is really useful. We have, by the way, a question by Jorge Medina. Sorry if I'm mispronouncing his name, saying that he wanted to thank you personally because he's using your code, your R code, for quite a lot of time, and he saved me many times. So
All right.
you have
Cool.
fun all over the world. And by the way, Alberto Quero said also that he's not mentioning your website, but he's using it when he's doing R. So I think that's a good reward.
Cool. Yeah. Thank you for the feedback, and yeah, to everybody using the website. Like, I really have that kind of feedback. That's actually the main reason why I'm building two sites. It's like to help people. What you can do, like, to thank me, if I made you think time, is to create some pull requests on GitHub to improve their content. So if you see a bug, if the code doesn't work, if my English is bad, please let me know, and that helps me having better websites.
Okay, good. So I think the message is sent. I have some other question very fast. Maybe by Ziad first. Does, in your opinion, R Markdown have an interactive feature? I know the answer, but you can.
Yeah.
He's asking if you can share your template, but I think your template is with your brand, so maybe not.
So that's two questions. So first question, it's indeed possible to insert some interactive charts into a R Markdown document. Actually, a R Markdown document is a HTML document. Well, if you output it to HTML. So it means that you're basically creating a website with your code. So it means that you can add anything into it, any kind of interactivity. Yeah, I had in my plan to show an interactive chart, but I was running out of time, so I went a bit too fast. Second question about my template. My template is called Eparate, and it's been the same for about 2 or 3 years, even though there are a few bugs, didn't get time to fix it. And the logo is different because there is one field at the top, like in the YAML header, that allows you to load any kind of logo. So maybe that person saw it with a different logo. And if you're interested in it, you can type pimp my RMD in Google, and you will see a lot of explanation about it.
Okay, so great. Jorge Camus is asking you about when integrating multiple visual into a coherent visualization, a story or dashboard, how do you structure it? What's the underlying logic of the structure of the dashboard? That's a big question.
Yeah, well, like, some people wrote a few books about that. So it's a very, very open question. So I'm not gonna be able to answer everything, but one advice I would like to give is try to understand what the question is and try to be able to answer this question. So basically, don't show everything in your dashboard, but try to answer the question. So let's say you're gonna have a first chart that is gonna give like just one big number, because that's the main question people are gonna be wondering. And then you've got a second chart that is gonna be able to go a bit deeper, but not too deep, and then show what's like not as important, just as an interaction that just like pops up or something like that. So basically, don't show everything on your dashboard, but try to understand what's the most important and show only that, and the rest using interactions.
Okay, and we have another question that I had the same yesterday almost. What's the best software to deal with big data or big data visualization?
So when you have to deal, that's another very open question. So I've presented 4 types of tools. So Excel, forget it. If you've got too many rows, you're basically not going to be able to open it. So let's not even talk about it. Then you've got all the tools you're clicking with. That's not going to work neither. They're going to like burn out if you try to put too big amount of data. So it means that you're going to have to code. That's the first thing. So if somebody tells you you're going to be able to analyze it without coding, that's probably not true. Then it depends what you need to do. If you're more like analyzing data, doing some data science stuff, some prediction, doing some big statistics or stuff like that, you're going to stick to R or Python. And to be honest, Python is a bit faster than R, especially for data wrangling, at least as far as I know, but some people could argue about it with me. So yeah, if you've got big data and need to do some data science, statistics, I would say go to Python. Then if you've got big data, but you have to display it on the web, you're gonna have to deal with JavaScript. And then instead of using D3 and adding some like divs or SVG areas in your browser to display the Vs, you're gonna have to use what we call Canvas or WebGL, that are specific tool allowing to display a very big amount of information on the screen. So yeah, I will say for the web, the keywords are Canvas and WebGL.
Okay, we have another question while Chiara is reconnecting. The question is quite technical, but just maybe a glimpse of an answer. Do you think JavaScript is going to replace, being replaced, sorry, by HTML5?
Oh no, sorry. So, so yeah, it's a bit like details about web development. But basically, when you're looking at a website, what you see is HTML. So HTML is not really a programming language; it's a markup language where you say, "All right, put this sentence in this color and put a rectangle here with this color." So that's HTML. Then you've got CSS. CSS is going to apply some style to all the elements that you have in the HTML file. And then JavaScript is what we use to animate the website. So basically JavaScript is going to help you to make this button, and when you click on the button, something happens. So when you build a website, you need HTML, CSS, and JavaScript, and there is no way you build a website without one of them.
Okay, I think we have to stop now, but not without thanking you so much for your time while you're in a busy period. I know that. And not that you're not surfing, but you probably will have other things to do in a few months, waiting with a son or a daughter. So we wish you good luck for that and a very happy end of the year. And thanks again for all the elements you provide on the web for all of us who program or interested in data viz, and thank you for this, I'm sure, very, very interesting presentation for all of those who want to start or are already expert in data viz. Thank you so much, Jan.
Thank you very much for inviting me. That was cool. I hope next time it will be with real people.
Yeah, let's hope so.
Bye-bye, everyone.
Thank you, Jan.